Hello, let's talk a bit about pull up and pull down resistors, how they work, and why we use them. Why you need them is the Arduino checks on the input pin if the signal is high or low. And if it's high, it triggers something, or if it's low, it triggers something. You can put a button in between to go between high and low. But there's also a lot of electricity in the air, and our bodies also have static electricity. And these wires you connect stuff to in your Arduino um, can work as antennas and pick up this electricity. And this makes the pin float. It makes it think it's high or low, what actually isn't, because it's reading this static electricity. And to solve this problem, we're using pull up and pull down resistors. Let's start with how a pull down resistor works. So this is the schematic. You have your 5 volts that is connected to a button, and then the button is connected to your pin, and also with the resistor to ground. To explain how this works, I will use the analogy of water, and water is the electricity flowing. And I drew that here. You have your Arduino here. Here you have your 5 volts, which is like a big tab that's always open and is water flowing. This is your button, and this can open or close this pipe. This is the connection where your wires connect to the pin and the resistor and the ground. So that is this connection basically. And the resistor is like a thin pipe, so less water can flow there, and it goes to ground. Imagine the button is closed, no water is flowing, so the pin doesn't detect any water. If we now open the button, then water can flow here, and it goes in here. And because there's a lot of water flowing, this entire thing fills up and goes up here. And then Arduino thinks, hey, there's water, so the button must be pressed. Because we have a resistor here, a little bit of water goes here and shoots up, but most of it will go here because this is too small to let that much water go through here. Okay, now with the electricity that's in the air and in our bodies, it's basically like a leaky roof. So these pipes leak a little bit. So let's close the button again. And the water outside slowly leaks through these pipes. And it will flow down. And because this is very little, it will go through the resistor and shoots up to ground. And this very little water interference will not reach the pin, so the Arduino thinks the button is not pressed because there is no water. And that's good. That's what we want. But what if we don't have this resistor? That's this scenario. If we open this button, water will flow, it will fill up this, and it will go into the pin, and the Arduino thinks, hey, the button is pressed because I detect water. But you still have the electricity in the air that will leak through and will slowly come here. And usually with the pull down resistor, it will flow away, but this case it isn't. So slowly it starts filling up, until it reaches this. And then the pin thinks, there's water, so the button must be pressed, and it starts doing stuff. As soon as it triggers, all this water drains, and then it starts again. And this means that even though you don't press the button, because the water is not flowing, the ground can fill up and still trigger the pin, even if you don't want that. A pull-up resistor, which circuits look like this, works in a similar way. It has the same purpose, but everything is flipped basically. So where in the pull-down resistor, if you press the button, the signal will read high because there is water, and if you don't press it, it will read low because there isn't water. A pull-up resistor works the other way around. So there's always electricity flowing unless you stop it with the button, and then it reads low. So if you press the button, it's low, and if you don't press it, it's high. So if you use this, you need to be aware of that while writing your code. The plus side of a pull-up resistor is that it's built into the Arduino. So you wouldn't need this resistor. You could do it in code, and it would use an internal resistor in the Arduino. To show it, I did put it in this drawing. It basically works like this. You have electricity flowing through the resistor, so a little bit of electricity, and it goes through the wire to the pin, and the pin will read high. So it's always high. If I then press the button, this electricity rather goes to ground, and none of the electricity is flowing through pin here, so it will read low, and that's you can use to trigger stuff. A pull-up resistor works like this, where you have your Arduino here, you have your 5 volts again, which is the water that's always flowing. Up here you have a resistor, which slowly lets water trickle into this box. You have a tube here, which goes to the pin. You have a button, which is basically like a trapdoor in this case, which open up the whole floor here, into this funnel into ground, if it's pressed. In a pull-up resistor, there's always electricity flowing to the pin. That's why it's always reads high unless you press the button. That's because water comes in here, it trickles in here, and then it pulls at the floor here, and it goes in here to the pin. So there's always electricity flowing. If you press the button, the entire floor comes out, and instead of pulling on the floor, it just goes straight into this funnel into ground, which means there's no electricity flowing here in this tube anymore. Nothing is going to the pin, so that Arduino knows, the button must be pressed, otherwise there will be watering through the pin. With the electricity in the background, it's not a problem now, because this little bit of electricity coming in here just pulls up here as well and goes in through this wire. But there was already electricity there, so it is just a little bit more, but that doesn't matter. And if the button is pressed and you have a little bit of this electricity in the background, it just also falls down, and it also doesn't matter because nothing is going in the pin. If you wouldn't have this resistor, it would look like this, and a lot of water would flow here. Actually, way too much water would flow here. It would go straight from here and then in here, and the flow rate is so high that Arduino cannot really handle it, because the faster it flows, the hotter it gets, and eventually Arduino will shut down. Same for if you push the button. There was so much electricity flowing in here that it just overheats. And luckily, your Arduino has a bunch of safety features, so it will just shut down and not damage anything. But if you do this too long, or you work on a project that doesn't have this safety features, things will start smoking, and you don't want that. So yeah, that's why you use pull up and pull down resistors. It's to avoid false triggers and floating pins that are caused by the electricity and static electricity in the air and in your body that get picked up by the wires.